Here we're going to look at topic 6, example 3, solve a compound inequality involving end. What is the solution of negative 12 is less than or equal to 7x plus 9 less than 16, and then graph the solution. I'm actually going to show two ways to do this, and you can choose your preferred method. But when you're setting these up, you can treat them as if they were two different inequalities, similar to what we did previously in example 2. I'm going to take the left side here. All right, this negative 12 is less than or equal to 7x plus 9, and I can solve that inequality. And then I'm going to take the right side here, which is 7x plus 9 is less than 16. So that middle piece where your variable is included in both your inequalities. However, the left one, the blue one, we have that negative 12, and the right one, we have that 16. So you can solve these separately. Solve them as if you would solve a normal inequality. Don't treat them any differently. So negative 12 minus 9 would be negative 21 is less than or equal to 7x. We would then divide by 7. We're dividing by a positive number, so the inequality sign is going to stay the same. So we have negative 3 is less than or equal to x. And I'm actually going to rewrite that, so it'll make my life a little bit easier. I'm going to say x is greater than or equal to negative 3. All right, it'll just help me out a little bit. Now, the next one, the one here in red, just solve as an inequality. So we get 7x is less than 7, and we divide by 7. So x would be less than 1. So I'm now going to graph this. The smaller number, again, we're going to be a little lazy here. We're just going to put the numbers that we need, is negative 3, and the larger number is 1. The x is less than 1 would be an open circle, and the x is greater than or equal to negative 3 is going to be a closed circle. Now, end statements should be shaded between your 2 points. Just be careful that you have the setup right. Be careful that you did everything correctly. But if I think about this, x is greater than or equal to negative 3, so that tells me that this should shade to the right. And the x is less than 1 tells me that this should shade left, which works in my favor. So all I'm going to do is I'm just going to shade between those two numbers, and I have my solution. Remember that this is an end statement, so a number in between these here, let's say this is like 0. 0 is both greater than negative 3 and less than 1. Same thing if I had negative 1 here, right? It is greater than negative 3, but less than 1, and less than 1. If I had a number over here, let's say 5, this 5 is greater than negative 3, however, it is not less than 1, so that doesn't fit my compound inequality of an end statement. Now, the other way you could solve these, and sometimes students prefer this, but it's really up to you. You have this problem here, and if you notice, if we go back to the first part of the problem, we subtracted 9, right, from both equations, and then we divided by 7. So your steps of isolating x are going to be the same in each part of this compound inequality. So what you're actually able to do is, instead of separating them, I can subtract this 9 from from all of the parts, the middle, the right, and the left side. So I'd get negative 21 is less than or equal to 7x is less than 7. So that's the subtraction of 9, which again we did where we split it up. We're just showing it as a compound inequality. And then I'm still trying to isolate x, so I would divide by 7. And I get negative 3 is less than or equal to x, which is less than 1. And now this tells me that my x values, my solutions, are between negative 3 and 1, which matches up with my graph. You have the choice of separating them and solving them, or keeping it as an inequality and solving it that way. You do want to be very careful if you do keep it as a compound inequality Watch out for dividing by negative numbers because once you start flipping the signs, sometimes the graph gets a little confusing. We might shade in the wrong direction, but that's kind of the case with just a regular inequality, or if we separate a compound inequality, we still have to be quite careful about how we're graphing them. So it's up to you. You can use the method on the left, you can use the method on the right. The method on the left obviously will be a little bit more writing, but it's kind of nice to treat them as individual inequalities. Sometimes it can get a little overwhelming, and having them separate simplifies that process. But the method on the right will save you a bit of time, it'll save you a bit of space, and a lot of times it's pretty clear how you should be graphing and what numbers or where to be filling in that graph. So again, it's up to you. Both methods work. Just pick your preference.